Number 17. Efren has been keeping data on the Calaveras County Frog Jumping Contest for several years. Look carefully at the stem and leaf plot he made for the top 8 jumpers in 2007, shown at right. If you're looking at this and thinking, oh my goodness, I do not remember how to read a stem and leaf, do not worry, you are probably one amongst many others who need a little bit of a reminder of how to read it. So I've created a quick example. I've just added an extension onto our stem and leaf plot. I added a 26 in our stem section and a 1 in our leaf. And I'm asking you, well, what does this number represent? Well, I'll tell you what, it's not 26.1. Remember, this is kind of like the tens section. So if you have 26 tens, that means you have 260. And if you have a 1 in the leaf section, that's like the ones column, so you would have 261. Cool. Let's try one more, just for extra practice. So let's say I had this number, 2, that I've added here. This number is not 2,612, but it is, you guessed it, 262. So with that under our belt, hopefully the cobwebs have been dusted off. We can now get going on letter A. And it says, what is the minimum smallest value? What is the maximum largest value? Well, I'm looking at my stem and leaf. It looks like that my bigger numbers are towards the bottom. This is in the 250 zone, 240, 230, 220s. Yes, so now I'm looking, okay, which is my smallest number? Would it be 221 or 228? If you said 221, you are correct. That is your minimum. And now for a maximum, you're going to the opposite side of your stem and leaf, down to the bottom. There's only one number down here, and that would be 256. Are there any outliers? Remember the cool trick about the stem and leaf plot. You can take your stem and leaf and you can kind of turn it on its side. You know, sometimes it's kind of hard to see just when you look at numbers. So if you kind of, visualize it like a histogram would be. So, you'd have one big frequency there, one there, and there. So does it look like there are any outliers? Anything that's separate from your data? Well, on my first glance of it, no, there doesn't appear to be any outliers. There's no, big space and then another number, or a big space that's like really low or really high. You may notice that the data is not balanced, so you could say that it's skewed. It looks like all the data has been kind of pushed onto one side of the graph, but that does not mean that there are outliers. So we get to answer that question. And are there any outliers in the data? No, there are not. Moving on to our final letter, letter C. Is it possible to find the median of the data from the stem and leaf plot? If so, find the median. If not, explain why not. Okay, so now I have to do some thinking. Can I find the median of this stem and leaf plot up there? Well, what do I need for the median? I need my median number. I need my numbers organized in least to greatest or greatest to least. I'm asking myself, well, does that meet that requirement? Are the numbers organized least to greatest? Yeah, they are. Least and then to greatest down at the bottom. So that works. And now I'm going to be able to cross them off. So can I find the median? Yes. And I actually really like finding the median, especially when it's already organized in ascending or descending order. So I'm going to cross out my smallest number, 221, and then I'm going to go up to my biggest number and cross out my biggest. Cross out my next smallest, and now cross out my biggest. Smallest, biggest, etc. It's kind of weird to read it, but I do have 2 numbers left. So I have 228 and I have 234. And remember, when we have 2 numbers left and we're trying to find the median, you have to find the average of those 2 numbers. So the first number I'm going to write down is 228, and then I'm going to add it to, that's right, 234. Cool. I add it up, and once I have that, then I can divide by how many numbers I used. So I used 2 numbers, I'll divide by 2, and that leaves me with the median of 231.